Hi, and welcome back to our class. In this lesson, we'll explore some key concepts that are central to cloud computing: virtualization, scalability, and elasticity. Understanding these notions is crucial for grasping how cloud services function and how they manage their resources. Virtualization and containerization are two fundamental technologies that make the cloud computing possible. Virtualization allows multiple processes to run on a single physical machine, sharing resources such as CPU, memory, and storage, while operating in a digitally separated environment, so that it can easily be managed, scaled, and deployed. Containerization is a form of virtualization where applications and their dependencies are packed together in an isolated container, enabling them to run consistently across different environments. The concept of scalability refers to the ability of a system to efficiently adapt to a variation of the amount of work received by the system by growing or reducing the infrastructure. This ensures that the system can maintain optimal performance and resource utilization as the demand fluctuates. Scalability can be classified into two main types. The first one is vertical scaling, which means adding more resources, like RAM or storage, to an existing infrastructure. For example, if a server is struggling to handle a load of an application, you can add more memory or processing power. Vertical scaling is simpler to work with, but gives you a single point of failure in your system. The second type is horizontal scaling, that refers to the increasing of the capacity of a system by adding additional machines or nodes to distribute the workload. Horizontal scaling is often more efficient for handling large-scale applications because it can provide virtually unlimited expansion, and is one of the key features of cloud environments, where resources can be distributed across many machines or data centers across the world. Cloud platforms such as AWS, Microsoft Azure, and Google Cloud allow companies to scale both vertically and horizontally, offering the possibility to choose the most appropriate scaling method depending on the application and the workload. While scalability is about the system capacity to grow, elasticity is the ability to dynamically adjust in real time to match the computing needs of a system. It is a quick answer to meet some unexpected demand by allowing to automatically adjust the infrastructure, up or down, based on the current workload. Elasticity is especially useful for applications with unpredictable workloads, such as e-commerce platforms or streaming services, where the fluctuation in traffic can be significant. Elasticity allows cloud services to automatically allocate resources when there is a spike in demand and release resources when the demand drops, ensuring that the company only pays for what they use. This is made possible through two automation techniques: autoscaling and load balancing. Autoscaling enables the automatic sizing of a number of resources in response to predefined rules or triggers. For example, if your application experiences a sudden surge in traffic, autoscaling can add more servers to handle the load. When the traffic decreases, it can remove the unnecessary ones, reducing costs. Load balancing, instead, is used to distribute the incoming traffic across multiple servers, ensuring no single machine is overwhelmed. It helps maintain performance and availability by routing traffic to the node with the least load. So, to give you a short recap about what we discussed today, virtualization is used to create flexible and isolated environments that can be quickly provisioned and managed, allowing applications to be consistent regardless of the machine where they run. Scalability ensures that companies can grow their infrastructure to meet increasing demands, either by adding more resources to the system with vertical scaling or expanding with additional machines using horizontal scaling. Last but not least, elasticity takes scalability a step further by allowing cloud resources to dynamically adjust in real time to meet changing workload requirements, reducing costs. Together, these principles ensure that cloud computing environments are highly adaptable and cost-efficient, meeting the requirements of companies of all sizes. There are several key benefits to employ scalability and elasticity in the cloud. First, users only pay for what they use, allowing companies to avoid the upfront high costs associated with purchasing physical hardware. In the second place, with scalability and elasticity, companies can guarantee that their application and services have the resources that they need to perform optimally, even during periods of high demand. This helps prevent slowdown or downtimes, leading to a better user experience. Elasticity also ensures that resources are adjusted in real time based on demand, minimizing the risk of either over-provisioning, which can lead to a waste of resources and costs, or under-provisioning, which can result in a poor performance or service interruptions. To conclude, virtualization, scalability, and elasticity are the core principles that make cloud computing powerful, flexible, and cost-effective. Understanding these concepts is essential for anyone working with cloud technologies, as they provide the foundation for building and managing cloud-based infrastructure and applications. This concludes our third lesson. See you in the next one.